So how many of you like TIG welding? Maybe just a quick show of hands. Anybody? Nobody? Bueller? TIG welding, by far and away, is probably my favorite welding process. I love it. I mean, it's almost meditative. Now, granted, I don't have to do this to keep the lights on, so that probably has a big influence on my perception. Yes, it's slow. You're probably not going to build a trailer for your truck using one of these. You could, but you probably wouldn't. But for small stuff, you really can't beat it. It's quiet, it's clean, potentially it's very precise. And unless you get into some fancy high-end welders, the sheer amount of materials you can weld with a TIG welder just makes it a clear winner for me, hands down. Now, I think I've mentioned this before. This is my go-to setup. I mean, it's on there 99% of the time. This is a CK Worldwide. It's a 17 size torch. This is in their language, it's a CK 150. This happens to be the rigid head. I bought this a few years ago as a kit with the hose. This is their Superflex cable. I think a kit like this at the time was $130, $140. I think it depends what kind of connections you get on the end and how long the hose is. But when I bought this, I also ordered the 9 size torch body. This is the CK 100. And again, this is the 150. This is a 17 size torch, and this, I think, is a 9 size. I do have a big burly 26 size, but that rarely comes out. And I'll be honest, this torch and this cable have just spoiled me. I really wouldn't have it any other way. And if you've actually tried one of these, you may know what I mean. There may be other flavors of these out there. I just happened to buy the CK Worldwide one. So no ill will intended to anybody else that makes a similar setup. Now this 17 size torch from CK is rated to 150 amps both in AC and DC. Most of the stuff I do down here is relatively small and the welds are brief, which is where this CK 100 comes in. And I think this is good only to 125, but as you can see it's much smaller. And I actually only recently ordered the CK 80. I'll insert a picture. It's like I don't think it's technically like a micro torch, but it's crazy small compared to these. I haven't actually received that yet. Maybe we'll take a look at it once it gets in. Anyway, I've never actually gotten a chance to try this because I didn't get the right connections. Let me take this apart. I'll show you what I mean. So the 17 came in a kit, so it was already connected. This hose sort of has a male gas fitting on there, and the torch has a female thread on the end. The smaller size that I ordered has a male fitting, so I've never been able to connect to this. And what I'd like to do is just make a quick connection to get this torch on this hose. Essentially just like a threaded coupling. Now, yes, I will be wasting some brass, and yes, I could probably just drive out and buy this, but I want it now. Luckily in this case, the connections are set up such that, the conical seats can still seal off on themselves, so I'm not really worried about gas leaking. I really just need to mechanically connect the two. If you plan on doing any screwing around like this at home on your own equipment, just be sure you know what you're doing. This single hose carries both the welding gas on the inside and the welding current through the fittings. Now, according to the CK literature, these threads should be 3/8 24. Let me find a little cutoff and we'll whip one of these up. All right, so it turns out I don't have any brass in small diameters. And in fact, even this piece is a little bit large to start off with. I'm throwing away 50% of it. But on the upside, it's bronze, so it's more expensive. Not gonna lie, this part would have probably benefited from a little bit more forethought, but I think it should work. Again, this just serves as a coupling between the two threads, and the seal is still happening between the brass parts. I've basically turned this into this. All right, for a minute there, I was worried that was going to bottom out. All right, there it is. Nothing left to do but build this out and give it a try. So you're looking at a collection of sort of my Tig Torch parts. If you're wondering why I have so many back caps, it's because of the fourth law of thermodynamics. If you drop something, usually the most expensive component is the first piece to hit the ground. I break a lot of these. Some of this stuff for the smaller 9-size torch is stuff I bought by mistake years ago. Order the wrong part number, get weird looking collets you've never seen. Too much of a hassle to send them back, but now I can finally use them. So you can actually see a bit of my tigging history here. When I first started off, I think like everybody else, I started with the standard TIG collets. Hold on, let me grab one of those. I started off with something looking like this. That looks like a collet for a 3/32, or 2.4 millimeter. I then discovered gas lenses and finally made my way to the stubby stuff. That one should probably be thrown away or rebuilt. But I really like setting up a torch with this really short hardware. Gets you a nice compact package. Anyway, I don't have gas lenses for the 9-size torch. That looks like it might be a 16th. Let me prep a small tungsten electrode, and I'll bring you right back. I don't know if you can see down in there. You see the small hole sort of in the threads coming up from the torch body? That, of course, is where the gas comes up. It sort of fills the head, and then the only way out is out of the holes in the collet. Now, in a standard collet, it's just sort of these ports drilled in the side. In a gas lens, it'd be coming through like those small screens. And then once the cup is installed, it sort of directs it forward towards your weld. All right, there's actually already a short piece of 3/32 electrode already in the box, so I'm just going to go with this. It's 2.4 millimeters. Now, the problem, maybe when you're first starting out at using torches this small, is that you'll go through a lot more tungsten. There's a minimum amount of tungsten this thing needs to hold on to. So for any given piece, you're going to be wasting at least, the last inch and a half of it. After that, you just physically can't sharpen it anymore and hold on to it in the torch. Now, if you use the entire tungsten with a long back cap, you have a larger package, but you can use that tungsten all the way up to the last inch or so. I've never quite liked this. I guess it depends on what you're working on. This always felt like it was going to take my eye out at any minute. But if you go to a really short back cap, well, let me just put this collet in here. Well, I guess I don't have that one. Going to a short collet means you have to cut your tungstens down, and every time you cut the full length of tungsten, you still have that 1 inch you need to hold on to. So if you cut this down into 3 pieces, you'll eventually be throwing away maybe half of it. You'll have 3 1-inch stubs at the end that you won't be able to hold on to anymore. It's maybe a little less than that, but you get the idea. I'm interested to see how the CK80 torch works. That has no back cap. So I think I may be able to take advantage of some of these stubbier pieces that I probably should just throw away. So maybe this gives a better idea of what's going on in the business end. Here you can see the electrode, the tungsten electrode clamped in the collet, and that's what carries all of the weld current. It's physically clamped in contact and is a continuous conductor from the welder all the way to the tip of the electrode. And then the holes are where the gas comes out, where the argon sort of flows and fills the cup. On a standard collet with the holes laid out like this, you see the gas has to sort of make a couple of bends, fill up the cup, and then eventually sort of push out and onto your weld zone. If you compare that to a gas lens, the gas lens inside basically has to still make the same bends, but the only way out is through a couple of fine meshes, those screens. And so the flow is a little smoother and more directed. And that provides for more efficient coverage. So as a consequence, you can use less gas, more electrodes stick out, And in the case of the stubby gas lenses and cups, the whole package is even shorter. So it's like a win-win-win-win. All right, let's see how this looks. So that's not much shorter, but we're comparing stubby gas lens to traditional collet. I think this with a gas lens and a short back cap would make this just tiny. Though the difference in weight at the end is noticeable. It's a lot more, I don't know, it's like writing with a pencil compared to writing with a big fat heavy Sharpie. Now, I'm pretty sure I mentioned this before, but I'm not a welder. I only play one on YouTube. Doesn't really take much Googling to find a good one either. And case in point, Jody, I owe you an apology, buddy. I know I busted your chops when you got those cyborg eyeball camera implants with the flip-down shades and the micro SD card. Man, you're right, it's tough welding with a camera between your legs. And I don't know what he does to get those gorgeous arc shots. So as far as welds go, technically speaking, this really isn't anything to write home about. I realize that. It's mostly the welder's ability to maintain a controllable arc at low current. I was also pulsing it. I think that was 5 pulses per minute. So really I just needed to point the torch where I wanted the bead to go, and the machine sort of took care of making it look nice. You may have noticed there was no filler here. And I was really just trying to get a feel for how this lighter torch felt compared to the 17 I've gotten so used to. Now, certainly you don't need a small torch or a smaller torch than the 17 to do these kind of welds. Again, it was just a feel thing. Now, I think here, the first two aren't so swell, but here in the beginning I was just trying to get a feel for the amperage. Stainless really runs away from a guy once you start getting some heat into it. And then shaky old man hands started creeping in. Slowly got better at kind of keeping that torch on point. And to be honest, I'm a little worried about that smaller CK80 coming in. I'm afraid that thing might actually end up looking like a seismograph needle, trying to do these sort of welds in my hands. But anyway, all in all, I think I really like it. It's a really comfy size for, up to around 80, 100 amps or so. Again, technically rated to 125, but I don't know if I'd want to push it. I think it feels good on the torch, but we'll see how it does. If I don't like it, I can always go back to the old 17. Well, that's it. Thanks for watching. Seeing as we're here, just a quick tip. If you plan to make your temporal prism out of stainless steel, you'll need to back gas it. Now here I've cut this open, but if you were welding something like a pipe or, a closed container, you'd want to fill the inside with argon. Basically purge all the atmosphere out. Because as you're welding, you're protecting the weld side, but the back side gets hot enough to oxidize. And again, if it's a pipe or an enclosure, you more than likely won't be able to climb and slide to clean that. This isn't super representative. This is a fusion weld. Again, no real filler. I wasn't too worried about penetration. I just wanted to close the seam up. But hopefully you get the idea. Welding stainless and you can't get to the back side, back gas it. Now finally, and don't ask me how I know this, and it's totally not related to my temporal prism, in the near future, I'll be releasing a build video of a stainless steel planter stand. In that video, I'll use some pickling gel, and I'll get a lot of questions. So let's just talk about it now. So if you've done any welding, you're probably very aware of sort of the heat-affected zone around the weld bead. Here you can see the discoloration that started at the weld and made it about, a third of the way down this piece of stainless. Now that heat-affected zone is problematic in a lot of instances, especially for like higher carbon steels, as it sort of changes the material properties locally around the weld. The weld is already usually a stress concentration, and so minimizing the amount of heat you put into the weld joint and post-processing is sometimes very important to the performance of the part. In the case of stainless steel, the heat-affected zone affects the material property of the stainless, rendering it, not stainless. Pickling paste, or pickling gel in this case, helps to mitigate some of that. This is essentially acid. I think it's actually hydrochloric acid. It's really strong stuff. And when you paint it on and leave it sit for a while, it'll clean that oxidation and passivate the material, meaning it restores some of that stainlessness. Now, the thing that's handy about this stuff is that it makes cleaning the welds very easy, and it sort of brings that stainlessness back. It takes away the discoloration. Now, you could do this with just like a wire wheel, some buffing compound, but if you already have sheet stock or tubing that's, say, got a high polish on it, you're going to have a tough time, at least in my experience. I have a tough time matching the finish around the welds to the finish of the rest of the material. Now, although this acid does leave a bit of a dull area, it's easier to brighten that back up than it is to go through, subsequent levels of sanding and brushing and buffing and polishing to kind of make it all look the way you want it to. And frankly, there are some places that are just hard to get with like a wire wheel. That may be accessible, with a small acid brush. So here I just have washed it off. This is the side that wasn't pickled, and this is the side that was pickled. You can see there's a little bit of a opaque line near that weld. What I did is I took the other side and just hit it on the buffing wheel. Again, pickled up to here and then buffed and as welded on the right. Now, the downside of this, of course, is that the pickling compound is pretty toxic stuff. Like I said, I think in my case it's hydrochloric acid. And once you scrub that into the heat-affected stainless, you get sort of this, again, like a toxic sludge. That needs to be neutralized and then washed off. And of course, it needs to be handled with care. Gloves, glasses, breathing protection. If you're doing something big, you'll probably want some pretty good ventilation. And here's how that little fusion weld bead looks after it's been cleaned up. And just for reference, a human hair is about 100 microns. Now, after that ugly lawsuit, I'm technically no longer a chemist, but I think what it does is it attacks the iron that precipitates out of the stainless when you weld it. This here is just an innocent piece of steel wool, and this is the pickling gel. So again, it's pretty nasty stuff. And also anything that those fumes run into will instantly rust. Now, if you spend a lot of your hard-earned money on nice tools, you'll realize just how scary that can be. I mean, not even to mention what it could possibly do to your lungs if you get that stuff inside you. And on that happy note, thanks again for watching.